Hello everyone, this is Arindam. So today in this video we'll be talking about object-oriented programming in Python or OOPS in Python, right? So lately what I have been seeing is that many consider this topic, OOPS, not really important for data professionals. And I am here to break that myth. And I'll showcase how exactly this is really important and useful, for data professionals. So in this video, we'll go over the basics, and in the next video, I'll show how, we can automate, the process by integrating OOPS concept with real data set. So let's get started. All right, OOPS. So what is OOPS? So object-oriented programming, right? This is a method used so that we can structure our program. Instead of writing it linearly, we can use OOPS so that we can write reusable or and efficient and organized codes. To start with, I want to give an example. Let's say I am a car manufacturer, and throughout this video we will stick to this example, right? So let's say I am a car manufacturer owner and making thousands and millions of cars. I want to store information of all manufactured cars, like their name, color, price, and so on. To do that, there are multiple approaches, but today we will see the efficient way of doing it. Now, if you ask any beginner or someone who has just got into the Python programming, right, they will most probably take it, a very basic way. So let's say if we look at the procedural programming or the linear way of writing code, then we will need to create different variables for each car. And in that case, the problem is that if we have thousands of car data, then we need to create thousands of variables. And most probably, the beginner or the person who has just got into the Python programming will go ahead with this procedural programming or linear way of writing code, right? So in this case, what would happen is that our code will be scattered and it will not be in a structured format. Also, let's say if in future I want to add a new feature of my car, apart from name, color, price, if I want to say the type of fuel or the type of transmission this car has, a feature, right? Then we need to modify whole variable, right? And this can be a task. And that is the reason the best way to go ahead with in such scenarios is to use our OOPS concept, object-oriented programming, classes and objects. Let me start with showing an example for same. Now in this example, first let me go ahead and write the structure of the OOPS, and then I'll explain what each and every you know thing in the structure determine, right? So for example, first thing that I will be going ahead and doing is I'll be creating a class. Okay, so I create a class over here. I'll let you know what the class means, right? Then I go ahead and create a method. This section is called method, right? So let's say I go ahead and create a method. I'll also let you know what the self parameter means. Then I go ahead and give the name. Then next thing that we need to do is create an object. This is the variable that I'll be giving. Vehicle is a variable that I am giving and I'm assigning to the class car over here. This over here I have created an object. Now we need to call this object. Now there are two ways of calling object. I'll show you the first way how you can call it, It's very easy to remember the first way of calling, but generally in the programming we use the second method that I'll show you. So the first way is you first call the car, then you call the method, and then you in the parameter over here you give the variable. This is one way of calling it, right? And the second way, which is much more preferred and which is always used, is you give the variable name or the object that you have created and the method name. Okay, so these are the two ways you can call the object. Okay, now in instead of if you see the difference between these two, you will ask me what is the difference. So in this first one, you know we are giving vehicle as a parameter, but in the second one we need not do that, because when we give vehicle over here, this will consider vehicle as a parameter and then call self. So we need not go ahead do this, make it so lengthy. We can go ahead and use this one. Now I will go ahead and explain what class, method, object, everything means, right? So what is the class that we see here, right? What does it mean? So the class that is here, let's say this is the start, or say the blueprint of our code. You know, you must be having a blueprint of anything, blueprint of Eiffel Tower, blueprint of Statue of Liberty, blueprint of your house maybe. And using that blueprint, you go ahead and then construct the actual, house or whatever is needed, right? So this class is basically a blueprint, right? Using this blueprint, we'll be creating an object, this object. And then what is object? So object, you can say it's a real world instance of the class, or in more layman term, I would say it's the copy of the class, right? If in general, if you ask anyone what is an object, they would say it's a real world instance of the class. But in short, I'd say that it's copy of the class, right? So there is no meaning of classes without object, and we cannot create object without classes. So even if you go ahead create class, but you do not create any object, that class has no meaning, right? And if you do not go ahead and create class and you want to create object, that is not possible, right? Now what is this car underscore details? As I said, this is method, right? Before I jump to explain what is method, I want to explain something called as init method, or called the constructor, right? Now, to explain that, let's imagine that if we want to add some more features, or say attributes, to our car, right? So in that case, what are we gonna do, right? So let me do one thing. Let me show you first how doing this without constructor, how we can add, and what would be the difference in the code, and why we actually require constructor over here. All right, so now I'm gonna show you how you know a code looks without constructor and with constructor. So basically, you know in both the codes you would see the difference, and I'll let you know what the difference are as well, and why it is you know suggested to go ahead with the constructor method, right? So let's go ahead. So first, let me show you one without the constructor or the init method. So I'm just gonna go ahead and create a class again. I'm just gonna pass, not gonna write anything inside the class, not going to give any uh, definitions, rules, or regulations, right? Inside under this class, I'm just gonna go ahead and directly, create an object. So here, okay, let me just go ahead and write the code for you, and then I'll explain what it is. So I've gone ahead and created two objects over here, right? Now, after I create the object, I will go ahead and, you know, give the attributes over here, assign the attributes. Okay, let's say, okay, and then we'll just go ahead and print them. See one thing. Let's make our work easy. There we go, and just run and let's see. Okay, this is one method. Okay, we'll quickly write down code for second one with the init method. Over here, I'm assigning the attribute in the init method itself, right? Okay, now, so you can see here, I just gave fast, I did not give any rules or regulations the way I'm giving here. I did not give any method over here. I'm giving methods over here. That is one difference that you're gonna see, right? Now, okay, let's go. Let's create an object. Then call our object, right? But here, what are we missing? We are missing to give these information over here. So let's say I'm gonna say this, the model is Camry and the color is red. Okay, here it's Hilux and here it's gonna be white. Okay, so I'm just gonna call it, and then okay, just let's run this. Okay, perfect, perfect. Now we have the result, and we have both codes over here. And what's the difference that we see, right? So if you see, if you do not use constructor in the code, then I am going ahead and creating an object first, okay, and then assigning the attributes, isn't it? That's what I am doing. So in this code over here where I have used constructor, I have assigned the attributes initially itself over here, and then we call them later, right? So this, don't you think, makes our work much more structured, right? And we need not assign variables manually when we use constructor. So you can see the major difference is that the assigning of the attributes or the variables you need not do again and again, because if you have you know thousands or millions of vehicle of data, then you'll just end up going ahead and creating variables or assigning the attributes, right? So this is much more structured, right? And in this you will also see that when we assign or initialize a variable, this init will call itself automatically, right? So also do remember that this init method, you know, runs every time whenever we go ahead and create an object. So if I would have just created one object over here, okay, it would have just this init would have called itself only once. But the number of objects that we create, the number of times the init method will run, right? So now we know why using constructor is important, as without using it can be a tedious job when you have so many attributes or variables to add. So it's good to use constructor in your code. Now we also have different types of constructor, right? So the first type is with no parameter, where you have just the self and you do not have any other parameters, right? The second is with parameter. You're seeing is with parameter init method or the constructor, right? And the third type is constructor overloading. So what happens in this constructor overloading is, let's say you have multiple init constructors inside a class. You just do not have one, but let's say you have another one over here with different parameters. Okay, so in that case, what happens? Last one, this one will override the first init constructor, right? So in many scenarios, when we are giving multiple init methods, right, we would not want that override to happen. So in that case, we can have a workaround or a fix, that is by using if-else condition or the args, right? And we can avoid the override to happen. So that is something too deep, and maybe we will cover that in sometime later, right? So now it's time that we have seen what is init method, and now we'll be jumping to the methods topic, right? So what is method, right? So we have covered, we have discussed what is class, what is object, what is init method or the constructor, right? Now, but what are methods? So methods are basically functions, okay? In other programming languages like Java and C, we call this function, but here in Python this is called as method. So what are these? So we can see that car underscore details is a method, right? It is defined inside a class and it works with objects. So it is defined inside the class and works with objects, right? So this method helps me define the behavior or attribute of my object. So if you see this car underscore details, right, that is over here, this car underscore details over here, right, this method will define how my object vehicle will behave when called, right? So this is inside the class car, yes it is, and then when I call my vehicle, object vehicle, then it'll show me the model and the color. And why is that? That's because of this method car underscore details, right? And these methods are always used with self keyword so that they can access the properties of an object. If you miss to put in the parameter self inside the method, then it will not be able to access the properties of object, right? So this was all about methods. We have discussed class, objects, init method, and the method, right? So now that we have understood the basic structure, you know, let us talk about the principles or say backbone of the OOPS concept. There are four principles that we should be knowing. The first one is polymorphism, second is inheritance, third is encapsulation, and the last one is abstraction. So we will see each one of them one by one, right? We will start with polymorphism and I'll explain you what it means in detail. Okay, so let's start with polymorphism, right? So the word polymorphism, so it means having many forms. The word itself means having many forms. In programming, polymorphism means same function or same method used for different objects and properties. Let me show you two examples. And now over here I have already written the code for you and I will not waste time typing here as it will increase the video duration. So I'll just go ahead and paste the code and then we'll discuss about the code. Okay, so here's the code, the first type, the duck typing. Okay, so just go through the code and you would see I created a class, then I created a method with self parameter. I created another class, then a method, okay, and then same another class, then the same warning method, okay, then I've created the object and call them. Okay, now even in this code I call the class, okay, I gave the method, I call the class again, okay, but you would see the differences here, right? This is not with the self parameter, rather this class is calling the parent class or the first class, right? We'll discuss about it. Now if you have gone through the code, you have seen it, right? Now if you see both example codes, what is common that we see here, right? In both the code example 1 and the code example 2, right? It is the method warning, right? Or the function which we named as warning, right? We see that it is present in every class, but at end they act differently when called. This is polymorphism. One method, one name, but different behavior. Now, this method in car class will act differently when called, and the same method warning in engine light class will, you know, behave differently when called, right? Same goes for method in airbag class, method warning in brake class, right? So the first example is the traditional method or called the duck typing, right? And the second one that we are seeing here is runtime polymorphism or called the method overriding. So the reason why this is called runtime polymorphism because you'll notice that there is parent and child class indicating inheritance usage in this, right? Uh, Inheritance again is a backbone of or major principle of OOPS, which we'll be discussing next, right? So this is inheritance, right? And this is with a mix of polymorphism, right? So also you would notice over here that I wanted to showcase that how you can call all methods in one variable at a time. So you can see over here that I created an object then called it, I created an object and then again I called it. But I wanted to show you how you can go ahead and call all of them at once, right? So I created an object, right? I put all methods in the list over here and then call them at a time, right? All right then. So to conclude, one name of method but different behaviors is polymorphism, and they are best used or the best suited when you want to reuse your code or for better flexibility, right? So this was all about polymorphism. Now let's discuss about inheritance. So what comes to our mind when we think of word inheritance? Child and parents, properties, yes. We carry traits, behavior, genetics, all these things, and all other properties from our parents, isn't it? And along with that, we also develop our own new habits as well. So this is what means even in programming and even in this concept of inheritance, which is one child class can reuse the attributes and methods of another parent class. Now there are a couple of different types of inheritance in Python, right? So we'll see about them. There is single inheritance, the basic inheritance example. Then you have multiple, multi-level, hierarchical, and hybrid inheritance. We will try to take one example code block and work on all these types of inheritances. So I have pasted the code over here, and the first one that you see over here is a single inheritance, that I was talking about. Okay, so in this single inheritance, we are seeing that we have a parent class and then we have a child class inheriting from the car, which is the parent class. Now, thing is, uh, when you go ahead and assign object to child class, you will still be able to access method of the parent class. And obviously you can access child class method as well. So this thing is applicable in all the inheritance classes. The second one as well that we are gonna see here, right? Which is our multiple inheritance, right? This is our multiple inheritance. So this is easy. It's just that child class can inherit multiple parent classes. For example, if let's say we had a third class over here, let's say start class engine, and let's say we had transmission, for example, then transmission could have engine and car, both of them, in them. So yes, just like this, engine, transmission. Then car can have engine and transmission, both of them. So this is multiple inheritance. Again, if you call car, you will be able to call method of engine, you'll be able to call method of transmission, and you'll be able to call the method of its own class, right? So this is multiple inheritance, right? And right, as said that child class can have multiple parent classes. Now let's see multi-level inheritance. What is it? So let's say there is a class which is named as class number 3 that inherits from class number 2, and then class 2 inherits from base class. This is how multi-level inheritance class works. So if I show you an example, then it will be clear to understand. So yes, see, we have class called grandfather, which has a method house, then father, which is inheriting from grandfather and then has its own method, then son, which is inheriting from father, right? So this is your multi-level inheritance. If I go ahead and assign the object or variable to son, I shall be able to call all the methods house, car, and bike, right? So this was our multi-level inheritance. Now there's a last one, which is hierarchical inheritance. In layman term, I would like to say this is as one father or one parent and multiple children. So let's go ahead and see its example as well. So as you can see, this is the example of hierarchical class. Here, one parent and two child classes, and both the child classes can inherit from the same parent class, right? And when you create object of child classes, you can call the parent class as well as the child class or method as well, right? So this was all about hierarchical, and then we will also see there should be another last one, which is hybrid. Alright, so the last one, which is hybrid inheritance. So as the name suggests, hybrid, that is mix of or combination of all the inheritances. Single, multiple, multi-level, hierarchical inheritance mix of all these inheritances in hybrid. No doubt the structure of this inheritance is going to be complex, but classes can be interconnected to each other through different inheritance methods. So this was all about all inheritances and hybrid inheritance. So till now we have discussed polymorphism and inheritance. So now we will quickly discuss encapsulation and abstraction. So now encapsulation and abstraction are really important topics and pillar of OOPS, and many a times people confuse between both. So what is encapsulation and what is abstraction? Let's discuss that. Encapsulation is, where you are wrapping the data, or say you are protecting the data in, uh, from others. You're putting it in a locker in simple terms, right? So, and whereas the abstraction is you're just hiding the complex functions. So let's say you have a house, okay, and then you have a kitchen which you do not want guests to see, right? So you're hiding it. You will most probably just put a curtain or some sort of division or something other just to hide it, put a door or block anything, right? You're hiding it, right? And then you have a locker inside your house, a safe where you put all your important stuff, right? So that is your encapsulation. And kitchen hiding, or blocking the view to particular area, is abstraction, right? So this is the difference, that is there. There is difference between protecting something that is not accessible at all until given permission and hiding something, isn't it? So it can be accessed, but it is better kept hidden for ease of use. Now, before I jump to encapsulation, right, I would like to tell or give you a quick idea about access modifiers. I'll also, if possible, share a link to access modifiers. So these access modifiers tell us how the variables and methods can be accessed. There are three types: public, protected, and private. As name suggests, public modifiers can be accessed from anywhere. Protected is only few people can access it. That is, access only allowed in class and child. And private is that it can be accessed only when inside class. Alright, so this was about access modifiers. I'll also try to share a link that you can read about them, right? So let's get started about encapsulation, and I'll show you a code where I'll try and demonstrate everything in detail. Alright, so you can see that I have created a class, manufacturer, and I have given, there are so many methods that you're seeing over here. So now let me start explaining everything one by one. Okay, so I created a class called car manufacturer. I created a constructor over here where I gave the variables, right? Brand, model, and price, right? Now, if you see here, this self.brand equals to brand. Okay, this is a public variable. Okay, so we know, you must have seen in all the codes above, that this is how we initialize a variable, right? Public variable, and it can be accessed from anywhere. Okay, now the next thing, you must be seeing that why I did not give self dot model, right? There is a single underscore before my variable. This is protected variable. As I was explaining in the access modifiers, public, protected, and private, right? So this can be accessed only inside class or subclass, right? This is your kitchen, the example that I gave, you know, brand, let's say it's that your house, underscore model or the protected variable is, one part of the house which you want to keep it protected. You do not want everyone to see it. Only limited people can go there. Let's say only family members or only your relatives. And then comes the last one, which is private variable. You see over here, which is price, right? This is double underscore price. This is a private variable. So this is that locker or the safe which can be accessed only by you. Okay, the same way this private variable can be accessed only inside class, not inside subclass, not anywhere else, only inside class, right? Same goes for our method, right? So these were variables and this is method. You see, show card details, right? This is a public method. Now, I went ahead and, on this print, which I would say is a behavior, okay, I gave brand and I gave model. You must be thinking why I did not give price, isn't it? So this is because we know protected variable, right, can be accessed only inside class, right? The private variable can be accessed only inside class, right? So that is the reason I will not be able to go ahead and put price over here. Whereas I can go ahead and use brand and model because it can be inside class, which is this, and subclass, which is this, show card details. That's why I can use public and protected variables, but not private variables. However, if I want to use the price, right, at any cost, if I want to display the price, I can go ahead and use the get price. So this setter and getter is also a topic that I will go ahead and attach a link for that. But the only thing setter and getter is responsible for is to set a value, getter is to get a value in the simple terms, right? Now, coming to our next method with a single underscore, which is protected method, right? Now, so again, same thing, single underscore, this is protected method, same like our variable. Now looking at my code, you must be thinking that there is something different, right? Are we supposed to always update in protected method because I have gone ahead and used updated over here? Then the answer is no. If I wanted to just create a protected method and display it, I could have done it. But just to demonstrate an update example, I have gone ahead and showed it. If I want to just display the protected method, then I can just go ahead and use this code as show model and just keep it as self and remove this new model over here. So let me show that to you. So you see here, so I have created a protected method called show model, and I need not go ahead and update anything over here. It will just display the model directly. Another way is, as I said over here in public method, that I can go ahead and use get price and use it, though it's a private variable. The same way I can go ahead and just use get model, right? But in this scenario, this will not keep the get model as protected, and this can be accessed anywhere, right? So if you want a protected method and want to display it, you can just do it this way. Okay, now coming to the update price again, you know this is again your private method because you see there are two underscores over here, right? So again, same question, why are we updating? It is not at all necessary that we update price for private method. I can go ahead and create a private method and then assign it in a public method, right? Because that's how it is called, right? So if I go ahead and what I can do is not the way we did it here for protected method. Rather, what I'll do is I'll create a private method and then assign that private method to the public method so that we can access it. It's not gonna be same as protected method. It's going to be different from protected method if we want to just display it, right? So let me just show that to you quickly. So you see over here, this was our first private method with the update command, and then this is our private method, right? Again, where we created a private method and then assign it to public method, no underscores that you see over here, right? So this is a public method, isn't it? We assign this private method in this public method over here that we see. So if you do not use update for a private method, this is how you will have to do it. First, create a private method and then assign it in the public method, right? This is how we'll have to do it. And again, I can use the get price, right, by using the getter, but again, it will not be a private method anymore, right? So let's see what's next that we have. And this one is again set price, the setter. This is how the setter is used. So I'll not go in depth about this. I will share a link so that you know you can understand getter and setter much more. All right. So this was all about the structure till here, right? Not going in depth of setter and getter, right? Because especially setter, right? Because if we do not want to update price, then there is no meaning of using setter in our command or our code. Okay. Now, this is that you see here is we are creating an object, right? So brand, model, and price. So this brand is we are calling our public variable, right? We are accessing our public variable. If you run this, you will get the output, no problem. But if you see here, this is model is what? Your protected variable. We are trying to access our protected variable over here. Now, when we run this, we will get, the output, but it is not recommended to run it like this. Okay, I will let you know how you can access these two, right? So this is our public variable, right? No problem. This is accessing our protected variable, will get output but not recommended to access like this. Then how do we access? Okay, so first option, right? If you have a subclass in which you have this protected variable, then you can access it. In our case, we do not have that. So let's say, you know, this example that I gave you, you know, uh, here, if we had, let's say, something more like inheritance, okay? So if show model, okay, if show model was the class and then you had a public class with show model inside it, okay, then you could have gone ahead and used model and it would have been easily accessed without any problem, right? And it is recommended to do that. So the first option is when you have a subclass or when you have inheritance structure, right, in which you have a protected variable, then you can access it. Okay. Now, right, as I mentioned, protected method works well when we have inheritance structure. Now the option 2 is using getter and setter. Again, it is when you want to go ahead and get model, right? When you go ahead and define get model over here, then you can do it, right? Apart from that, again, you can even make it like, you know, you go here and create a protected method and put that protected method in a public method. That's the third option that we have, right? But the most recommended and the safest way to do is using setter and getter, right? So just use get model and you can do it. Okay. How do we access the private variable now? We have seen how to access public method, how to access protected method. How can we access the private variable, right? So you must be thinking that the way we called the public variable and the protected variable will also call the private variable, right? So protected variable, you can call this way, but it is not recommended. You can just use get underscore model, this one, and you will get it. Now, even for this, let's say I will just run this and show it to you, right? This throws an error. You cannot call it this way, right? How you can call this? The same way, use the getter method to call a private variable. See, we had given get price, isn't it? And if I use the same get price, I'll get the price. Okay. Now we have seen how we can access the three variables, right? Public, protected, and private. How about we see how we can access our methods? Okay. So it is pretty easy for public method accessing public methods. If we just go ahead and run show cards used, if you run this, you will get your public method. You must be thinking this is how we will go ahead, and call our protected method. I'll show you what happens in that case. Now, because we had two protected methods over here, right? One with the update, one with, you know, need not update, right? Now, if I go ahead and use this, right, protected method, this will work, right? Again, the same. It will work just like protected variable. We will get the output, but it is not recommended to access the protected method like that. As I said, you can get the protected variable by using, getter, but for protected method, you cannot use getter. The reason, because setter and getter is only for the variable, right? It does not make sense to use getter or setter for protected methods because the getter setter motive is to control only the variables and not methods. That's why it will work only with the variables and not with methods. Okay, so what can we do in that case, right? The same thing which we did with the private method. We created a private method and then assigned it in the public method. The same way, I created a protected method, and if I go ahead and create a public method over here and assign, you know, the protected method inside that public method, then I can go ahead and access it. So even if I go ahead and run this, call this over here, access this, then it'll throw an error, right? So let me just go ahead. Now, next I will discuss about the abstraction, right? So as I mentioned, abstraction is hiding unnecessary features and showing just what is essential, right? So I can relate this or tell you, uh, if let's say you have ever worked in a product-based company, because I used to work for one, and they will only tell you information that is necessary for consumers to know. So if let's say if they go ahead and expose all the technicalities, and then it is very easy for anyone to do a reverse engineering or to find the loopholes in the product, right? So no product is perfect. There are always minor issues, and they know that consumers are very smart, and they never underestimate the customer. So if anyone needs to stick in the business and grow, then they should know that it's never a good thing to expose all the technicalities to the consumers, their loopholes, because once it's exposed, then it's very hard for them to stick in the market. Alright, enough of the business tech talk. Let me show you a few examples on the abstraction. Alright guys, so this is the code that I was talking about. So for abstraction, first you need to import this ABC module, and then you can go ahead and start writing your code. So when you write, for example, this class, and you want to make this class as abstract, okay, then you need to give ABC for that class, okay, and then give an abstract method for the subclasses or the methods, right? So this class is abstract, right? These two methods are abstract method. This is not an abstract method. This is a normal method, right? So again, I have created the abstract class. Now I created another class Honda, which inherits from this class called car, right? So now when the major difference, right? The main thing to remember when you're writing an abstraction code is that, for an abstract class, you can never create an object. Whenever you try to create an object for an abstract class, it will throw an error. And that's why here I went ahead and gave inheritance of car in this Honda class, so that whenever I create an object on Honda class, I can still access, you know, this fuel type, not these two, because these two are abstract methods and they are hiding, right? We are not supposed to show them. So, you know, it will show fuel type start stop of Honda class, not of car class, right? Same goes when I created a Tesla object, right? So this is how your abstraction works. And in case if you do not want to use ABC module, and if you want a quick uh, you know uh, code that you want to write, then there is something called as not implemented error. You can even use that. Okay, in that case also, what happens is when you create uh, the object for the abstract class, at that time there will be no error, right? But when you go ahead and uh, try to create an object for that abstract method, then it will throw an error. For example, if I in that not implemented error, the second type, if I go ahead and create object for car, it will work. But when I create object for these two methods, it will throw an error. Just give me a moment, I'll try to show that to you as well. We'll try to wrap it as quickly as possible. This is how not implemented, or the second alternative of abstraction method looks like when you use not implemented error. That means this is an abstract method, right? So this is another way of doing it, okay? And this was all about abstraction. I thought before I show how OOPS is important with data sets, it would be good to know OOPS structure. So in next video, I'll try and demonstrate how OOPS is used in real time by data professionals. Right? Thank you.